In the hushed boardrooms of Brussels and the gleaming factories of Germany's industrial heartland, a chilling realization has taken hold. Europe's technological backbone is fracturing under the weight of a geopolitical storm. In October 2025, amid escalating trade frictions, Chinese authorities imposed stringent export controls on semiconductors produced by Nexperia, a key supplier embedded in the global supply chain, effectively halting shipments critical to European industries. This move, described by some as a furious retaliation against Western encroachments, has plunged the EU's tech sector into crisis, with assembly lines grinding to a halt and projections of widespread shutdowns looming. As automakers from Volkswagen to BMW warn of production stoppages and tech giants scramble for alternatives, the question arises: how did a dispute over a single chipmaker escalate into a threat capable of paralyzing an entire continent's innovation engine? This is not merely a trade spat. It is a stark reminder of how dependence on foreign semiconductors has left Europe vulnerable, facing the prospect of a total shutdown in its tech ecosystem. To comprehend the magnitude of this development, we must first explore the foundational role of semiconductors in the modern world, a technology so ubiquitous yet so intricate that it underpins nearly every aspect of daily life. Semiconductors, often called chips, are tiny electronic circuits made from materials like silicon that conduct electricity under specific conditions. They are the brains of devices, controlling everything from smartphones and computers to cars, medical equipment, and even household appliances. Explain their function simply. A chip processes information by switching electrical signals on and off billions of times per second, enabling computation, memory storage, and connectivity. The global semiconductor industry, valued at over $500 billion annually, is dominated by a handful of players. Taiwan's TSMC produces the most advanced chips, while companies in the Netherlands like ASML provide the specialized machinery extreme ultraviolet lithography tools that etch circuits at nanoscale precision. Europe's position in this ecosystem is both influential and precarious. The continent excels in design and equipment, home to ASML and Infineon, but relies heavily on Asian manufacturing for assembly and raw materials. China, emerging as a semiconductor powerhouse since the early 2000s, controls significant portions of the supply chain, particularly in mature nodes, older, less advanced chips essential for automotive and industrial applications. China's rise stems from massive state investments under initiatives like Made in China 2025, launched in 2015 to achieve self-sufficiency in high-tech sectors. This plan poured trillions of yuan into subsidies, research, and acquisitions, allowing Chinese firms to capture market share in areas where Western companies had offshored production for cost savings. The EU's tech sector, contributing over €2 trillion to the economy and employing millions, is deeply intertwined with these global chains. Automobiles alone account for 40% of Europe's chip demand, with modern vehicles containing thousands of semiconductors for everything from engine control to infotainment systems. The sector's vulnerability was laid bare during the 2021-2022 chip shortage, triggered by COVID-19 disruptions which idled factories and cost the auto industry hundreds of billions. Since then, the EU has pursued strategic autonomy through the European Chips Act of 2023, allocating €43 billion to boost domestic production. However, progress has been slow. New fabs, chip fabrication plants like Intel's in Germany, remain years from full operation, leaving Europe dependent on imports, particularly from China, for legacy chips. The tensions culminating in China's 2025 export halt trace back to broader geopolitical frictions, where semiconductors have become weapons in a tech Cold War. The US-China rivalry set the stage. Starting in 2018, Washington imposed export controls on advanced chips to China, citing national security concerns over military applications. These restrictions, tightened in 2022 and 2023, limited sales of cutting-edge technology from companies like NVIDIA and AMD. Explain export controls simply. They are government rules prohibiting the sale of sensitive goods to certain countries, aiming to prevent technological advantages from aiding adversaries. China responded with countermeasures, including investigations into U.S. firms and restrictions on rare earth exports, minerals essential for chip production, where China holds 90% of global processing capacity. Europe, caught in the crossfire, sought a balanced approach. The EU labeled China a systemic rival in 2019 but maintained extensive trade ties with bilateral flows exceeding €800 billion annually. Semiconductors. Featured prominently, China supplied over 20% of Europe's chips, particularly for automotive use. Tensions escalated in 2024 when the Netherlands, under U.S. pressure, restricted ASML's exports of advanced lithography machines to China. Beijing viewed this as alignment with Washington's containment strategy, straining relations further. Step by step, the events leading to the 2025 halt unfolded with escalating acrimony. In early 2025, the Dutch government, citing national security, initiated a review of Nexperia, a semiconductor firm acquired by China's Wingtech in 2019. Nexperia, headquartered in the Netherlands but with factories in China, produces discrete chips, basic components like diodes and transistors, vital for cars, phones, and appliances. The review culminated in October 2025 when Dutch authorities effectively nationalized parts of Nexperia's operations, blocking exports from its Chinese facilities and seizing control over intellectual property flows. This move, justified as protecting critical infrastructure, was perceived in Beijing as an expropriation of Chinese assets, violating investment treaties. China's response was swift and targeted. On October 28, 2025, the Ministry of Commerce announced export controls on Nexperia-produced chips destined for Europe, halting shipments pending compliance reviews. Initially framed as a temporary measure to ensure civilian use, it quickly expanded to broader restrictions on semiconductor materials, including gallium and germanium, rare earths used in chip manufacturing. By November, the curbs affected over 70% of Europe's imports of these components, leading to stockpiling and price surges. European firms with inventories lasting only weeks began rationing supplies. Volkswagen announced production halts at 3 plants by mid-November, citing chip shortages. Negotiations ensued, but progress was halting. In early November, EU officials confirmed partial exemptions for automotive chips, allowing civilian use exports to resume under strict conditions. However, broader restrictions remained, with China linking full resolution to the Nexperia dispute. By December 2025, the halt had morphed into a de facto embargo on advanced semiconductor tech, exacerbating EU shortages amid ongoing US-China tensions. Hidden or less discussed factors illuminate the strategic calculations behind China's actions, factors that transcend immediate retaliation. First, the Nexperia case symbolized broader anxieties over foreign takeovers. Wingtech's acquisition was part of China's outbound investment strategy, but Western scrutiny, fueled by fears of technology leaks, has blocked similar deals, prompting Beijing to weaponize its supply chain dominance. Rare earths, where China controls the market, serve as leverage. Restrictions imposed in April 2025 on 7 elements remain in effect, disrupting EU AI and renewable sectors. Domestically, the halt aligns with Xi Jinping's dual circulation model, prioritizing internal markets while selectively engaging abroad. By curbing exports, China redirects chips to domestic firms like Huawei, accelerating self-reliance amid U.S. controls. Less visible is U.S. influence. The Netherlands' action followed Washington's diplomatic push, highlighting Europe's subservience in the tech war. Internal EU divisions play a role. Germany, with deep China ties, advocated dialogue, while France pushed protectionism, delaying unified responses. The EU tech sector's potential shutdown stems from this dependency. Automotive production, Europe's largest chip consumer, faces immediate peril. Estimates suggest a 20% output drop without alternatives, costing billions. Broader tech, telecom, consumer electronics, medical devices relies on Chinese legacy chips, with diversification years away. Job losses could exceed 1 million, straining welfare systems. Global implications ripple outward, reshaping alliances and economies. The U.S., while insulated by domestic production, faces indirect hits through allied supply chains, prompting calls for transatlantic chip alliances. Emerging markets benefit as China redirects exports, fostering South-South ties but heightening dependencies. Trade fragmentation accelerates, tariffs and controls proliferate, slowing growth by 1 to 2% annually per IMF projections. Innovation suffers, EU firms delay R&D amid shortages, ceding ground to Asia. Environmentally, disruptions slow green tech rollout like EV batteries. Politically, it fuels populism. EU elections see anti-China rhetoric rise. In conclusion, China's 2025 halt on chip exports to Europe, born of fury over the Nexperia seizure, has thrust the EU tech sector toward a potential total shutdown, underscoring the perils of supply chain fragility in a divided world. What began as a dispute over a single firm has evolved into a test of resilience, revealing how semiconductors, once obscure components, now dictate geopolitical fortunes. The EU's scramble for alternatives amid partial exemptions highlights the need for true autonomy, but the path is fraught with costs. This episode invites reflection. In an interdependent economy, weaponizing trade risks mutual harm, eroding trust and prosperity. Solutions lie in diversification, diplomacy, and innovation, forging alliances that transcend rivalry. As Europe's factories dim, the lesson endures. Technological sovereignty is not luxury but necessity, ensuring progress amid uncertainty. The halt may thaw, but its chill lingers, a cautionary tale for a world where chips hold the key to power. As negotiations between Beijing and Brussels drag into the closing weeks of 2025 and the early months of 2026, the partial exemptions granted in November for certain automotive semiconductors offer only fleeting relief, while the broader export halt on advanced and legacy chips from Chinese-controlled facilities persists, pushing Europe's tech sector deeper into operational paralysis. The exemptions, limited to civilian end-use components with strict verification requirements, including end-user certificates and on-site audits, cover roughly 30% of pre-crisis volumes, sufficient to keep some assembly lines limping along but far short of restoring normal production. Major automakers facing inventories depleted to days rather than months implement rolling shutdowns. Volkswagen extends halts to additional plants in Wolfsburg and Emden, BMW curtails shifts at Munich and Dingolfing, and Stellantis idles facilities in France and Italy. By January 2026, industry associations estimate a 40% reduction in European vehicle output compared to 2024 levels, translating to lost revenues exceeding €100 billion in the first quarter alone. Step by step, the crisis's progression reveals a calculated escalation rather than a blunt embargo. In December 2025, Chinese customs authorities begin enforcing dual-use classifications more stringently, recategorizing certain power management chips, essential for electric vehicle inverters and industrial motors, as potential military applications, thereby subjecting them to full export bans. This reinterpretation, justified under updated regulations from the Ministry of Commerce, affects suppliers beyond Nexperia, including SMIC foundry products and discrete components from firms like Hua-Hong Semiconductor. European importers, accustomed to just-in-time delivery, confront lead times stretching to 6 months or more, prompting emergency air freight at premium costs that erode already thin margins. Telecom operators reliant on base station components delay 5G network expansions, while consumer electronics manufacturers like Philips and Bosch postpone new product launches. The EU's response, coordinated through the European Commission, unfolds incrementally but with evident constraints. In late November 2025, Trade Commissioner Valdis Dombrovskis announces a chip diplomacy task force, tasked with securing alternative supplies from Taiwan, South Korea, and the United States. Negotiations with TSMC yield commitments for increased legacy node capacity at its Arizona and Japan fabs, but delivery timelines extend into 2027 due to existing backlogs. South Korea's Samsung and SK Hynix offer marginal diversions from domestic priorities, contingent on EU subsidies and regulatory relief. The United States, through the CHIPS Act framework, prioritizes its own industry, leaving Europe to compete for secondary allocations. By February 2026, the Commission activates emergency procurement mechanisms under the Single Market Emergency Instrument, authorizing stockpiling and rationing protocols reminiscent of pandemic-era measures. Less discussed amid the immediate supply crunch are the cascading effects on innovation ecosystems and research pipelines that threaten Europe's long-term technological competitiveness. Universities and research institutes, dependent on imported chips for prototyping in fields like quantum computing and artificial intelligence, face project delays. Consortia under Horizon Europe funding report suspended experiments, with grant reallocations needed for alternative simulation-based work. Startups in the deep tech space, clustered in hubs like Eindhoven and Dresden, struggle to attract venture capital as investors reassess supply chain risks, leading to a 30% drop in funding rounds during the fourth quarter of 2025. Established firms redirect R&D budgets towards software solutions, over-the-air updates to extend hardware lifecycles, but hardware-dependent breakthroughs in areas like autonomous driving and advanced robotics stall indefinitely. Another obscure dimension involves labor market disruptions and social consequences that extend far beyond factory gates. Temporary layoffs, known as Kurzarbeit in Germany, surged to levels not seen since the COVID-19 crisis, affecting over 500,000 workers by spring 2026. Supply chain SMEs, small and medium enterprises specializing in wiring harnesses, sensors, and assembly, face existential threats. Insolvency filings in the automotive supplier sector rise 40%, triggering regional unemployment spikes in areas like Baden-Württemberg and Catalonia. Retraining programs funded jointly by national governments and EU recovery funds target digital skills, but absorption capacity lags, exacerbating youth unemployment and fueling social discontent. Geopolitical undercurrents further complicate resolution efforts. The Nexperia dispute, at the crisis's core, evolves into protracted arbitration under bilateral investment treaties, with China filing claims at the International Center for Settlement of Investment Disputes alleging expropriation. European leaders, divided on approach, Germany's chancellor advocating quiet diplomacy to preserve export markets, while France and Poland push for reciprocal measures delay unified retaliation. Proposals for carbon border adjustments or anti-coercion instruments gather support but face implementation hurdles, as any tariffs risk inflating already elevated energy and material costs. By mid-2026, alternative sourcing strategies yield mixed results. Investments under the European Chips Act accelerate. Intel's Magdeburg fab breaks ground ahead of schedule with additional state aid. GlobalFoundries expands Dresden capacity for automotive-qualified chips, and ST Microelectronics partners with Taiwan for joint ventures. Yet scaling to meaningful volumes requires years, leaving interim gaps filled by costly stockpiles and rationing. Diversification to Malaysia and Vietnam for assembly offers partial relief but introduces new vulnerabilities: labor standards, geopolitical stability in Southeast Asia. The global implications of this prolonged halt reshape technological and economic alignments in profound ways. The United States, observing Europe's plight, intensifies friendshoring initiatives, prioritizing chip allocations to allies while advancing domestic capacity through private-public partnerships. Taiwan, as the world's foundry linchpin, gains leverage, extracting concessions on security guarantees and investment protections. Developing nations, excluded from high-end supply chains, deepen ties with China, accepting yuan financing for local fabs in exchange for resource access, entrenching a bifurcated tech landscape. Innovation trajectories diverge. Europe's focus shifts towards software and systems integration, strengths in embedded intelligence and cybersecurity, while hardware leadership consolidates in Asia. Green transition goals suffer setbacks. Electric vehicle adoption slows amid production constraints, delaying EU carbon reduction targets. Defense applications, reliant on secure chips, prompt accelerated military-industrial collaborations, blurring civilian-military lines. Financial markets reflect ongoing uncertainty. European tech indices underperform global benchmarks by 20% through 2026, while defense and software firms outperform. Sovereign bond spreads widen for periphery nations dependent on manufacturing exports, straining Eurozone cohesion. In contemplating the enduring fallout from China's chip export halt, the EU tech sector's brush with total shutdown emerges as a pivotal moment in the geopolitics of technology, one that lays bare the consequences of strategic dependence in critical domains. What originated as a furious response to perceived expropriation has morphed into a sustained leverage play, testing Europe's resolve and exposing the limits of half measures in achieving autonomy. Partial exemptions and diplomatic overtures offer temporary salves, but the underlying vulnerabilities persist, demanding accelerated investment and coordinated action. This crisis compels broader introspection on the nature of global supply chains in an era of great power competition. Interdependence, once celebrated for efficiency and growth, now carries strategic risks that no single bloc can ignore. For Europe, the path forward requires not merely diversification but resilience, building redundant capacities, fostering talent pipelines, and forging equitable partnerships that mitigate coercion without isolating innovation. As factories flicker back to partial life and negotiations inch toward potential resolution, the lessons crystallize. Semiconductors are not commodities but foundations of sovereignty in the digital age. The halt's fury may subside, but its imprint endures, urging a reevaluation of how nations balance openness with security, cooperation with competition. In this precarious equilibrium lies the challenge and opportunity to construct a technological order that serves collective progress rather than perpetuates division. Europe's trial by shortage, painful as it is, may yet catalyze the resolve needed to secure its place in a multipolar world, where chips determine not just economic fortunes but the very contours of As the crisis precipitated by China's semiconductor export halt stretches into the latter half of 2026, the EU tech sector's struggle evolves from acute shortage to chronic adaptation, with partial exemptions proving insufficient to avert widespread operational contraction and forcing a fundamental reassessment of industrial strategy across the continent. The exemptions expanded marginally in March 2026 to include certain power semiconductors for renewable energy applications following intensive lobbying from German and Danish officials, now cover approximately 45% of pre-crisis import volumes. Yet this incremental relief arrives amid depleted stockpiles and escalating costs. Air freight premiums and verification compliance have added 20 to 30% to procurement expenses, squeezing margins for manufacturers already contending with energy inflation and labor shortages. Automotive production, the sector most acutely affected, stabilizes at 60% of 2024 levels by mid-year, but with permanent capacity reductions, several plants converted to component storage or repurposed for software development centers rather than full assembly. Step by step, the EU's mitigation efforts gain momentum but reveal the immense inertia in reshaping global supply chains. The European Chips Act's funding disbursements accelerate. By July 2026, over €20 billion are committed to specific projects, including TSMC's joint venture fab in Dresden, set for initial production in 2028, and Infineon's expansion in Villach, Austria, focusing on silicon carbide chips for electric vehicles. National initiatives complement this. France's Plan France 2030 allocates additional billions for ST microelectronics, while Italy supports partnerships with global foundries. Yet fabrication timelines remain immutable. Advanced nodes require 3 to 5 years from groundbreaking to volume output, leaving interim dependencies on non-Chinese sources like Samsung's Texas facilities and Intel's Ireland operations, both operating at capacity serving primary markets. Diplomatic channels yield mixed outcomes. A high-level summit in June 2026 between President Xi Jinping and European Commission President Ursula von der Leyen produces a framework agreement for phased normalization, contingent on resolution of the Nexperia dispute through compensated divestment rather than outright nationalization. China agrees to lift restrictions on legacy nodes for civilian applications by year-end, in exchange for EU commitments to resume ASML maintenance contracts and ease visa restrictions for Chinese engineers. Implementation, however, stumbles over verification mechanisms and lingering mistrust, with full resumption delayed into 2027. Less discussed in policy circles are the profound shifts in corporate strategy and innovation priorities that the crisis imposes on European firms, shifts that may redefine competitive advantages for a generation. Research and development budgets, once balanced across hardware and software, tilt decisively toward digital solutions, over-the-air updates to extend vehicle life cycles, cloud-based computing to offset embedded processing limitations, and AI-driven predictive maintenance to mitigate component failures. Companies like Siemens and Schneider Electric pivot toward edge computing architectures that minimize reliance on imported chips, while automotive giants invest heavily in zonal electronics, consolidating functions to reduce chip counts per vehicle by 30% in next-generation platforms. Another under-examined consequence involves the human capital realignment sweeping through Europe's tech workforce. Engineering talent, facing project cancellations and delayed prototypes, migrates toward software domains or relocates to less affected hubs like Israel and the United States. Brain drain accelerates. Reports indicate a 15% increase in European STEM professionals seeking opportunities abroad in 2026, straining university-industry partnerships and widening skills gaps in semiconductor design and materials science. Retraining initiatives, scaled up through EU social funds, target mid-career workers from traditional manufacturing, but cultural resistance and curriculum lags limit efficacy, leaving pockets of structural unemployment in regions historically tied to hardware production. Geopolitical ramifications continue to unfold with subtle but far-reaching effects. The crisis bolsters arguments for de-risking within transatlantic alliances. Joint US-EU task forces on critical minerals secure diversified sourcing from Australia and Canada, while coordinated export control regimes harmonize restrictions on dual-use technologies. China's leverage, while potent, incurs costs. Domestic overcapacity in legacy chips emerges as exporters seek alternative markets, pressuring prices and profitability. Relations with the Global South deepen. African nations receive preferential HIP allocations in exchange for mining concessions, entrenching resource for technology exchanges. By late 2026, Economic modeling projects a cumulative GDP drag of 1 to 1.5% across the Eurozone attributable to the halt and its aftermath, with recovery trajectories varying by member state, Germany and the Netherlands suffering most acutely due to export orientation, while service-dominated economies like Spain fare relatively better. Inflation dynamics shift. Initial supply shocks ease, but wage pressures from labor market tightness sustain core rates above target, complicating European central bank policy. Financial markets reflect this protracted uncertainty. European tech valuations remain discounted 25% relative to global peers, while defense and cybersecurity firms attract premium multiples amid heightened geopolitical awareness. Sovereign debt dynamics strain periphery nations, prompting renewed discussions on joint borrowing instruments. The broader global implications crystallize in an accelerated bifurcation of technological ecosystems. A splinternet in hardware emerges. Western-aligned supply chains prioritize secure, albeit costlier, sources, while China-centric networks scale rapidly for price-sensitive markets. Innovation velocity diverges. Europe excels in regulated domains like medical devices and industrial automation, leveraging stringent standards as competitive moats, while Asia dominates consumer-scale applications. Environmental goals face recalibration. Delayed electrification in transport slows carbon reductions, prompting compensatory measures in buildings and agriculture. Social cohesion tests endure. Public discourse polarizes between advocates of strategic autonomy and proponents of renewed engagement, influencing electoral outcomes in key member states. In surveying the long arc of the semiconductor crisis, China's export halt, initially a furious rejoinder to the Nexperia intervention, has catalyzed a profound reckoning for the EU tech sector, averting total shutdown through painstaking adaptation while exposing the perils of asymmetric dependence. Partial exemptions and diplomatic progress offer bridges toward normalization, but the scars remain. Truncated production, redirected innovation, and recalibrated ambitions. This episode illuminates fundamental truths about technology in the 21st century. Semiconductors are not mere components but arteries of modern civilization, and control over their flow confers influence rivaling traditional power projections. Europe's trial has underscored the costs of delayed sovereignty, financial, industrial, and strategic, while highlighting resilience in diversity and ingenuity. The path ahead demands sustained commitment. Accelerating domestic capabilities without protectionist isolation, forging equitable partnerships that distribute risks, and investing in human capital to sustain innovation ecosystems. As shipments resume incrementally and factories regain rhythm, the crisis's legacy may prove transformative, not as defeat but as catalyst, spurring a European technological renaissance grounded in self-reliance tempered by cooperation. Ultimately, the halt's fury, though tempered, leaves an indelible lesson. In an era where chips dictate destiny, no economy can afford complacency. The EU's navigation through this storm, fraught yet resolute, offers hope that adversity can forge strength, ensuring the continent's tech sector emerges not diminished but redefined, capable of contributing to a multipolar world where innovation serves shared progress rather than entrenched division. As the supply lines mend, the imperative endures: secure the foundations of tomorrow's technology today, lest future disruptions prove more consequential still. As the calendar turns to 2027, the semiconductor export halt imposed by China in late 2025 begins to recede from the forefront of daily headlines. Yet its transformative effects on the European tech sector remain indelibly etched into the continent's industrial fabric, marking a decisive pivot toward a more guarded, self-reliant technological posture. The phased normalization agreement reached in late 2026 gradually restores shipments. By the first quarter of 2027, 80% of pre-crisis volumes for legacy and mid-range chips resume under a new bilateral monitoring framework that includes joint audits and dispute resolution mechanisms. Advanced nodes, however, remain restricted for European end users without special waivers, ensuring China's leverage persists in cutting-edge domains. Automotive production rebounds to 85% of 2024 levels by mid-2027, with full recovery projected for 2028 as new domestic and allied fabs come online. But the interim years have exacted a toll measured not only in euros but in lost momentum and recalibrated ambitions. Step by step, Europe's adaptation matures into structural change, with the crisis serving as an acceler. For policies long debated but slowly implemented. The European Chips Act's ambitions bear fruit incrementally. Intel's Magdeburg facility commences pilot production in early 2027, specializing in automotive-qualified processors, while TSMC's Dresden joint venture achieves first silicon yields by summer, focusing on 28-nanometer nodes critical for industrial applications. National champions expand aggressively. Infineon invests an additional €10 billion in power semiconductors at sites in Germany and Austria, bolstered by state guarantees and EU recovery funds. Smaller nations contribute niche strengths. Sweden's rise in silicon carbide materials and Belgium's advancements in photonics integration create a distributed ecosystem less vulnerable to single-point failures. Corporate strategies evolve in parallel, reflecting lessons learned from near-shutdown conditions. Automakers redesign vehicle architectures around chip efficiency. Zonal controllers consolidate functions, reducing semiconductor counts by up to 40% in new models launched from 2027 onward. Software becomes the primary differentiator. Over-the-air updates enable feature additions without hardware changes, while partnerships with U.S. cloud providers like Oz and Microsoft deepen to offset processing constraints. Consumer electronics firms pivot toward modular designs, allowing easier component swaps and extending product lifecycles in anticipation of future disruptions. Research consortia funded through expanded Horizon Europe allocations prioritize open-source hardware initiatives, fostering European standards that reduce proprietary dependencies. Less discussed amid the recovery narrative are the enduring social and regional disparities that the crisis has exacerbated, disparities that challenge the EU's cohesion and social model. Industrial heartlands in Germany's Ruhr and Bavaria, France's Grand Est, and Italy's Lombardy endure prolonged elevated unemployment, with supplier ecosystems shedding permanent jobs as larger OEMs consolidate sourcing. Retraining programs achieve partial success. Hundreds of thousands transition to software engineering and renewable energy roles, but structural mismatches persist, particularly for older workers in specialized manufacturing. Migration patterns shift. Tech talent flows toward dynamic hubs like Berlin, Paris, and Stockholm, hollowing out peripheral regions and intensifying urban-rural divides. Public sentiment, tracked through Eurobarometer surveys, reflects lingering resentment toward globalization's risks, fueling support for policies emphasizing economic security over unfettered trade. Another underappreciated legacy involves the crisis's impact on European innovation culture and risk appetite. Venture capital, once buoyant in deep tech startups, adopts more conservative postures. Funding rounds prioritize near-term commercialization over moonshot hardware research, with average deal sizes declining 15% in 2026-2027. Academic industry collaborations strengthen in applied fields, battery management systems, sensor fusion, but fundamental semiconductor physics research suffers from equipment shortages, delaying breakthroughs in areas like gallium nitride transistors. The brain drain moderates as domestic opportunities expand, but a generation of delayed projects leaves Europe playing catch-up in quantum and neuromorphic computing. Geopolitical realignments solidify as byproducts of the ordeal. Transatlantic tech cooperation deepens through frameworks like the Trade and Technology Council, yielding joint standards for secure chips and coordinated investment screening. Relations with China stabilize at a managed competition level. Trade volumes recover modestly, but with heightened due diligence and diversified sourcing mandates embedded in corporate governance. China's own semiconductor ecosystem advances rapidly during the halt period, achieving breakthroughs in 28-nanometer domestic tooling and expanding EUV research, narrowing the gap with leading-edge foundries. By 2028, economic assessments quantify the crisis's cost at over €500 billion in lost output and investment delays, equivalent to roughly 3% of cumulative EU GDP over the affected period. Growth trajectories recover but with a lower baseline. Projections revise long-term potential downward by 0.5% annually due to reduced capital efficiency and innovation drag. Fiscal burdens mount. Subsidies for chip projects strain national budgets, prompting debates over Eurozone fiscal transfers and debt mutualization. Financial markets reflect this matured landscape. European tech valuations converge toward global averages by late 2027, with semiconductor-related firms trading at premiums reflecting perceived security. Sovereign risk perceptions stabilize as diversification progresses, though periphery premium spreads remain elevated. The broader global implications manifest in a more fragmented yet resilient technological order. Supply chains bifurcate permanently. A trusted Western-aligned network emphasizes security and redundancy at higher costs, while an open Asian-centric ecosystem prioritizes scale and affordability. Innovation diffuses along these lines. Europe strengthens in regulated, high-reliability applications like aerospace and medical devices, contributing to global standards that influence even rival blocs. Environmental objectives, initially derailed, regain momentum through necessity-driven efficiency. Reduced chip counts per device lower energy consumption in use phases, while domestic production shortens transport emissions. Social equity considerations integrate into policy. CHIP Act funding increasingly ties to regional development and inclusive training mandates. In the final reckoning, China's semiconductor export halt of 2025-2026, though rooted in fury over specific grievances, has profoundly reshaped the European tech sector, steering it away from the brink of total shutdown toward a more sovereign, albeit costlier, future. The crisis's resolution, through phased normalization and accelerated self-reliance, demonstrates both the limits of economic coercion and the tenacity of adaptive institutions. This transformative period illuminates enduring truths about technology's role in statecraft. Critical components are not neutral but bearers of strategic weight, and dependence invites vulnerability in an age of rivalry. Europe's journey through shortage and scarcity has forged resilience, not through isolation but through deliberate diversification, deepened alliances, and renewed commitment to innovation's foundational enablers. As production lines hum at restored capacities and new fabs illuminate the horizon, the Halts legacy endures as catalyst rather than catastrophe. It compels a mature recognition. Technological progress thrives not in unchecked interdependence alone but in balanced ecosystems that safeguard core interests while embracing collaboration's benefits. The EU emerges tempered, its tech sector leaner, more focused, and better positioned to contribute meaningfully to a multipolar world. Ultimately, the fury that sparked this crisis has dissipated into lessons etched deeply. Sovereignty in critical technologies is imperative, yet achievable through foresight rather than fear. As Europe charts its course in this redefined landscape, the imperative remains clear: to nurture innovation that serves societal needs, bridges divides, and withstands pressures, ensuring that the digital age advances human potential rather than fractures it. In the quiet restoration following disruption, the seeds of renewal take root, promising a technological future built on wisdom gained from trial.